Hi, my name is Sadie Merton, and this is my Lab 2 for Physics 2211. I conducted a lab exploring the motion of a falling object with and without the effects of a drag force. I analyzed the motion of the object using the tracker software, then used GlowScript to create a model and graph the object, first without the effects of drag, then with the effects. This lab examines Newton's laws and the momentum principle. Newton's first law states that an object in motion will remain in motion until a force acts upon it. Newton's second law states that the net external force equals the change of momentum of a system divided by the time over which it changes. The change in momentum is the difference between the final and initial values of momentum. In this lab, I will compare the experimental motion of the object to the predicted motion of the computational models from GlowScript. The two forces we will see in this lab are the force of gravity and the drag force. The force of gravity, which is also known as the weight force, is found by multiplying the mass of the object by the acceleration due to gravity. The acceleration due to gravity is 9.8 meters per second squared. The drag force, which is the main focus of this lab, is always going to be in the opposite direction of the object's motion. Because of this, we should expect to see the drag force slow down the acceleration of the object. For the purpose of this lab, we will be using 0.5 meters per second squared as our drag force. In the tracker software, you can see that I have set the y-axis to be the center line of where the brick falls, and the y-axis to be the floor where the brick hits. This means that the brick will fall in the negative y direction. The software tracks the brick as it falls down from rest and plots the data to the right. The data collected from tracker shows the y position decreasing at an exponential rate. The slope of the position time graph shows the object's velocity. Since the slope is exponential, it showcases a non-constant velocity as time changes, which indicates that the net force acting on the object over time is a non-zero force. In the first computational model, we will use the variable b in line 79 to neglect the force of drag and assume that the only force acting on the object is the force of gravity. In line 78, you can see that we use negative g because the force of gravity is in the direction of the brick, the motion of the brick. In the calculation loop, the object's velocity is updated using a kinematic equation derived from the momentum principle. The new velocity is equal to the object's initial velocity plus the net force over the mass of the object multiplied by the change in time. The net force is found by adding the drag force and the force of gravity. When we do the second computational model, we will use the variable BD in the place of the variable B to include the drag force. Here you will see the computational model negligent of the effects of drag. Notice the time velocity is a constant slope. This is because the net force is constant as the velocity changes over time. Here is the computational model after taking in the effects of drag. Here the time velocity graph has a non-constant slope. As the object continues to fall, its velocity is increasing, which also increases the force of drag. These two graphs show a side-by-side comparison of the computational model's graphs, which is the green line, overlaying the graph derived from the tracker software. On the right, you can see that the force of drag has a much more similar slope to the observed graph. Now, let's say that instead of dropping the brick from a position of rest, it was thrown down with a negative velocity. To model this scenario, I changed the initial velocity of the object to negative 0.3 meters per second squared in the negative y direction. Here you can see that there is no effect on the terminal velocity, only the amount of time that it takes to get there. Since the properties of the object don't change when the initial velocity changes, the magnitude of the force due to gravity and the magnitude of the drag force will remain the same, and the same goes for the terminal velocity.